1, 2, 3.
Hello. In the last class, we are discussing about the vectors and scalars. What is vector? Vector is a quantity that require magnitude and direction. Scalar, we only require magnitude. What is magnitude? Yes, for 4 meter. Okay, is a length. Quantity is a length. So 4 is the magnitude. That type of things we are discussing in the last class. Now I am asking a question. Suppose a 6 kilogram apple is there and a 4 kilogram apple is there. When it combines together, we get 6 plus 4 is equal to 10 kilogram. Okay. Now another thing. That is, suppose it is a bench. Okay. I am applying a force 10 Newton and 10 Newton in this direction. Okay. The same force I am acting in this one and this is in this direction, this is in this direction for this point. So I am asking you, the both the conditions, both the total force. We know 6 kilogram apple and a 4 kilogram apple, when we add it together we get 10 kilogram. Here 10 Newton force, each one 10 Newton, or we can change the magnitude. 8, this will be 8. So here also we can get 10 Newton and 8 Newton are the forces acting on it. Okay, but what happened here? Yes, the direction is different. Okay, here the force 10 Newton and 8 Newton. Okay, in the same direction. But here it is a opposite direction. Okay, so my question, we know 6 kilogram apple and 4 kilogram apple when we mix it. If it is in first this 4 kilogram apple, first we put and 6 kilogram apple, next it is put. In both the conditions we get 10 kilogram. But what happened here? Simply we can say that 10 Newton and 8 Newton are the forces acting on the bench. But in one condition, this 10 Newton and 8 Newton are in the same direction. But this 10 Newton and 8 Newton are in opposite direction. Whether the total forces is same? No, it is different. Here 10, 8, same direction, so we obtain 18 Newton. 10, 8, we get 2 Newton. Both the condition 10 is a vector, so we put, suppose it's a vector, so we put vector 10, we give a hyphen like that. Here 8, we given hyphen like that. In both the conditions we are adding. Okay, we are adding. But in one condition, the first condition we get 18 and second condition we get 2. But 6 kilogram apple and 4 kilogram apple, when we are mixing together, every time when we add, we obtain 10. No other values. Then why it is happening like this? The reason behind is that 6 kilogram apple, 4 kilogram apple, kilogram, which is quantity? Yes, mass. Mass is what? A scalar quantity. So, for a scalar quantity, sum, we can simply add the what? Simply add the numbers. 6 plus 4, 10. But here, the force is what? It is a vector quantity. So, when we add two vectors, we consider, yes, the direction also. That is why in the same direction, we get 18. But in opposite direction, we get 2. So, sum, when we add the quantities, we can split into 2. We already split the quantities in vector quantity, scalar quantity according to the direction. If it is magnitude only, it is a scalar quantity. If it is a magnitude and direction, it is a vector quantity. For the sum also, the same change. Scalar sum or algebra sum. This is vector sum. Algebra sum means simply add. But in the vector, we want to also look at the direction. Okay. So this is a very important topic. So now we move to the next section. That is, this when the two forces are acting in the same direction, we get 18 Newton. When in opposite direction, we get 2 Newton. But if the force acting perpendicular, that is 8 Newton and 10 Newton. So what's the resultant? What's the total force? In this condition, the first condition, 10 Newton and 8 Newton are in the same direction. As a result, we get 8 Newton. But in the second condition, 10 Newton and 8 Newton are in the opposite direction. At that time, we get only 2 Newton. At that time, on in another way, that if it is 10 Newton and 8 Newtons are perpendicular, what's the resultant? How can we add? Suppose it is not being perpendicular. Suppose it is acting like that, say 10 Newton acting, okay, and 8 Newton acting, and make the angle sometimes say 60 degree or 40 degree. So what's the result? This is the problem. This is a problem. In the same direction, we can simply add the vectors. If it is in opposite direction, if we want to find the sum, simply subtract. But in this condition, if these two vectors are acting perpendicular or making angle with each other, at that time we cannot add. Simply add. Like the same direction or opposite direction, subtracting to opposite direction. We can't do like that. For this, we want something. For what we do that? Suppose we want to add two vectors, which is not in same direction or opposite direction. Same direction or opposite direction, what will happen? Same direction, it is very easy, simply add. But in opposite direction, simply subtract. But different angle, if this comes perpendicular or any other angle, we know. For this, we want to study something more. So that is known as, before saying about that theory, we can discuss how it is approached. Suppose we want to add this 10 Newton and 8 Newton force. Okay, 10 Newton is the and 8 Newton force. We don't know how to add. So the scientists make a theory to find help from the mathematics. Through that they make a theory. What they make theory is that this 10 Newton and 8 Newton, you are considered as the adjacent side of the parallel. So it has a name that we can discuss later. First of all, we are discussing how it is approached. They are approaching like that. To add two vectors, what we do that? Take that two vectors as the adjacent side of the parallelogram. So adjacent side of the parallelogram means that there are two types we can add. Suppose this 10 Newton and 8 Newton, if we take this, we can put here. At that time 10 Newton here, and these two are considered as the parallelogram. Otherwise, also there is other opportunity. What is that? We can put D here also. Okay, but here in the case of parallelogram, in this condition, we are take the vectors when we connect. One is tail or head. Already we studied, this is head, this is tail. So when we add 10 Newton and 8 Newton, we put this 10 Newton force in the tail of the 8 Newton. Okay, clear? Clear? So if we, first what I say, if we want to add two vectors, consider the two vectors as the adjacent side of the parallelogram. When we consider the adjacent side of the parallelogram, what we do that, we take the vectors as the adjacent side and put whether the tail coincide or head coincide. Here what we do that, the tail coincide. Okay, so I consider two vectors. So I make it bigger that we can discuss. 8 Newton and 10. Okay, I made